Everyone. We are going to look at the intuition for coding binary search using recursion. So I have my IDE open and let's make some logic for doing the binary search using recursion. So let's say I have this problem. I need to return the index of the element if found, or else we are going to return -1. And let's say my function is binary search and I want to find k. So this looks like the function. Let's say the problem you are given has a function declaration looking like this. Now, the first thing before we start coding and make some strategy, we see that we for a binary search we need a left and a right, and this function does not have a left or right, so we cannot use this function directly to do a binary search. We cannot take any local variables, because let's say if I do this, okay, this is not going to work, because let's say you do some calculation and you call this again, you will have new instances of ln(r). For a recursive function, we need something which stays and which creates a subset of the original problem. So then what we learn from this is we need a separate function. So if you are doing lead code problems or any of the problems, you can create your own functions which supports your primary function. You can take members, class members. This is all fine. This is very important. You should know that you can take extra things in your class when doing lead code problems. So I'm going to create another function. Let's say underscore r, and then I need a left and I need a right. So this declaration looks good. Okay. Okay. So now what we need to do is we need to call this function from our main function. So my left is going to be 0 and my right is going to be the length of the array -1. Okay, this, I think, no, we don't need any strategy to write this line. Why do we need length -1? Because if we say only length, this is going to be out of bounds. So let's say my array is this. Now its length is 5, and if I am going to send 5 to this function, I might go out of bounds if I try 5 on this array, because the maximum index is 0 to 4. We cannot do 5. So it's always safe to stay within the bounds of your array. So I think this looks okay. And we will just return what we get from the recursive function. So this is fine. I will make it public so that someone can call it. I'm going to make it private because I don't want this function to be called directly from outside the class. This is an internal function which is called only by binary search function. Okay, now if you have done binary search iteratively, what we are going to do. So let's say I need to find k is equal to 3. My left is 1, my right is 5. Let's write the indexes. So 0 and 4, right? Now I'm going to calculate mid. So my mid becomes 2. Mind it that these are indexes. So nums2 is 3 and this is my middle. Now what we actually do, we either go left or we go right, or probably we will find the element. So if the element at mid is less than the element which we need to find is less than the element at mid, we go on to the left side, and if it is greater, we go on to the right side. Okay, so let's say instead of 3 we want to find 2. What would be the calculation? This means element at mid, which is 3, and what we want to find 2. So k is less than the value, okay, because 2 is less than 3. So we need to go on to the left side. So if we go on to the left side, now you see this is my left, this is my right. I am here. When I am here and I haven't found the element, so if I want to go on to the left side, my left side is going to be this, right? Okay. And my right side is going to be this. So I can say my left is going to stay the same. L will be same. And R is going to be M minus 1, right? Because I am here and I want to change M to 1 less than the mid. And in case we wanted to find 4, then we want to go on to the right side, because now my k is 4 and my nums3 is 3. So k is bigger, which means k is going to be on to the right side of 3. So then I want to move on to the right side. So my L is 1, my L is 0, my R is this. So my L is going to shift from this position to this position, and my right is going to stay the same. So then L will be M plus 1 and R will be R, correct? So this is the intuition, okay? Now, when we talk about recursive functions, we need a base condition and then we need the calculation. Okay, let's see. So a few things which I already know is, I know, let's say I know some base condition. I want to go until my left becomes right. So let's say my base condition is until my L and R reaches together. If that happens, I haven't found the number, so I am going to return -1. So this is my base condition, okay? Now after the base condition, what I'm going to do is I'm going to calculate mid. This is pretty normal. So my mid is going to be R minus L divided by 2. Okay. Now what I'm going to do is I will check the element at mid if that's equal to k, less than k, or greater than k. So let's see. If k is equal to nums m, I am just going to return the index. correct? This is pretty straight, I think. And if I haven't, so either what can happen if k is less than nums min, so k is less than the number at the middle, which means it's less than, it's on the left side of the middle. So which means we want to move my right to the left side, right? So I am going to call this function again recursively, but this time onto the left branch, which means left will remain same, but my right will become this, right? Otherwise, I know that my k is bigger, because these are the only three cases which can happen. So in this case, I want to go on to the right side. And if I want to go on to the right side, my L will be moved towards the right and the right will remain where it is. So my L is going to be one right of the middle and my right will remain same. So now this is looking okay. If I don't find, I return -1. If I find, I return the index. But what about the rest of the places? Because eventually I need to return something, okay, from the function. Okay, let's say I'm not able to make some logic. So let's say I just return mid from here. So this is my logic at this time. Okay, let's try to run this code. And r dot binary search 1, 2, 3, 4, 5, and let's take the simplest case, so that, because I know what I know is, maybe there are problems, but what I know is this is not right, because I have put this without giving it a thought, and I need to do a little debugging to figure out what I should be returning if this is not met and this is not met, right? So let's see what happens. I need to find 3. I'm going to debug the code. Okay. Okay, I have L, R, M, and this I have added to the watch. So my L is 0. This is the first call to the function. R is 4. L is smaller than R. We will move forward. We will calculate mid. Mid becomes 2. So my array is 0, 1, 2, 3, 4. Okay. This time I think we will find it, because k is 3 and nums 2 is 3. Okay. So we will return index 2. Fine. And looks good. Let's say, okay. And I'm going to print it. Okay, good. Now this simplest case is working. Let's try to find 2. Okay. Let's debug again. Okay, 0 and 4. We calculate mid. And nums 2 is not equal to 2. We want to find k, which is 2. So my k is less than nums2, which means I need to move on to the left side. Okay, and so I think this is the condition. Okay, so I'm going to go on to the left side, so my L will remain same, but my mid, which is pointing here, will start pointing here. So this is going to be my right, and this is going to be my left. So my sub array becomes 1 and 2 because we moved on to the left side. Now we will call this function again. Okay, we called it again, and we calculated mid again. This time mid is 0. Okay, so mid is 0, so we are matching with this. Now if we are matching with this, but my value of mid, which is 0, and my value is 2, which is greater, so we are going to go on to the right side. Okay, now we came here, my L is 1, R is 1, and something is not right, because this is going to return -1, and we keep returning -1, and eventually we will return -1. But here it is actually returning index 2. So why? Because we are returning from here eventually. This was not right. Okay, let's look at it again. I think I know what the problem is. So let's move to where, okay, so there are two problems. The number was present, we didn't find it. Secondly, we returned -1, but eventually at the end, we got a 2 here. We should have got -1. Let's say we didn't find the number. So at least we should be getting a correct result from here. Okay, so let's see. We keep doing this. Okay, so eventually we figured that 2 is not present in the array, let's suppose, and we returned -1. So if you look at the stack here on the left side, we are here. Who called it? The one below on the stack. So if we click here, so we called from here and then we reached here. So when we are going to unwind the stack from here, the previous call was from here. Okay, so we are going to reach here. As soon as I return -1, see, I reached here. Now that's the problem. Can you figure it out? We got -1 here, but we lost that result. We didn't save it. What exactly we want to do? We want to return, keep returning as soon as we know that either we have found something or we haven't found something. That's our result. We need to keep returning that result. Okay, so that's the problem with this code. The problem is, as soon as you got the result, you need to return, keep returning that value. And here also. So when somebody returns -1 or somebody returns an index which was found, the previous call will be either this or this, because you reached here or you reached here. But from where you reached? This was probably from here or here. You will keep calling this function again and again, and eventually you will reach here or you will reach here. So when you return from here, the result will be either here or here, depending on from where you called. Now you need to keep returning that result, right? You cannot do that. So this was one mistake which we found. So that's the thing. We made some logic, we coded it, but there are small flaws in the code which we are trying to fix. Our general strategy is fine, but there are a couple of small bugs in this. Okay, so we save it. Let's run it again. Okay. So first we are going to fix that our return value should be retained. Okay. So we reached here -1 and we called that from here. Now we are returning -1 from here. And who called this one? If we go into the stack, we reached here from here. So when I'm going to return from here, I will reach here. Look at the stack. Okay, that's how you will find. See, we reached here. And now from this place, who called this? If we go into the stack, okay, so that was our first call. And before that, we called from here. So now here we are returning again -1, which will read here. Then again, we are returning -1 and which will reach here. And okay, nice. So now you are retaining your results, which is good. Now let's figure out why we are not able to find 2. Okay. Um, okay. Let's see. My L is 0. My R is 4. We calculate mid, which is 2. Okay. So 2 is this. So we want to find this one, and my mid is here. Because k is equal to 2, it's on to the left side. We will go on to the left side. So we will go on to the left side. Now that is the problem. The problem is we are not taking care of our mid. We either go on to the left side and leaves mid. We either go on to the right side and leaves mid. We never take care of the mid value. That's the problem. So see, now when we are going on to the left side, see, previous mid was here. So either we need to have a very specific rule. When we are on to the mid and we want to go on to the right side or left side, so one side has to include this mid. So if we want to go on to the right side and not include mid, so then my left will be this and my right will be this. But then in that case, if we want to go on to the left side, my right is going to be this and my left is going to be this. So this is the logic. This is one logic. When I move on to the left side, my left side is going to retain the mid position. So my right should start from the mid position. This is one logic. Somebody can say, no, when I go on to the right side, I am going to include mid. So in that case, when you go on to the left side, so this was your mid, and you don't want to include your mid when you go on to the left side. So then your left will be this and right will be this. And when you go on to the right side, you are going to include mid. So then your left will be this and right will be this. The problem here is either we make the right, which is one less than mid, and either we make our left, which is one more than the mid. We never include mid, we just leave it. So if we go here, now see, okay, now it's 0 and 1. That is the problem. And then we calculate mid, which is 0. So probably it was easier for me to find because I have done more code. I figure out things very easily when I do a little debugging. And maybe some experience, I remember that, okay, this is the mistake I'm doing. Okay, let's try this again. Run it. Mid, okay, the first calculation was fine. Now this time, my L is this and I am including mid. So my right is this and not this. Okay, came here. Nice. My mid is 1. Okay, so this is mid. I found it. I'm going to return it. Index. So this was, do you remember from where we called? We went on to the left side, which means when we reach here, before that, we were here, right? So once we return, we will reach here. See, now what we are going to return is, we are going to return the result, and the result is 1. 1. Okay, looks fine. Let's do a couple more cases. Let's say I want to find 5. Let's say what happens. Okay, so 0 and 4. Mid will be this index, which has a value of 3. Okay, it's not matching. We want to go on to the right side. So that's our right side. So when we go on to the right side, my left will be, this was my mid. So my left is going to be this index, which is 0, 1, 2, 3. And my right will be 4. Okay, good. Okay, nice. Left is 3, right is 4. I'm going to calculate mid. Mid will be 3, 0, 1, 2, 3. Okay. So, okay. Okay. I want to go on to the right side. That's fine, because my left is this, my right is this, and my mid is this. So it's onto the right side of mid. So my mid will be 4 and my right will be 4. Okay. So L is greater than equal to R, and we did find it. Why? Because fourth element, my L is 4, R is 4. My fourth element is still valid. I haven't checked my fourth element and I'm returning, right? What is the fix? I want to include when my L is equal to R. That's still a valid index. I cannot ignore that, which means let's need to fix. Now it's fine. When L will be bigger than R, then we will say that, okay, this is a invalid scenario. When L is equal to R, it's still a valid scenario. We are at the very end of the array, and then my L and R will be equal, but it's still a valid scenario. Okay, let's see. Okay, 0 and 4. So we want to go on to the right side. We went to the right side. So my mid was 2. Now my mid is going to be 3 and my right is going to be 4. Okay, this is fine. Now my mid is going to be 4. Sorry, 3. And so which means we still want to go on to the right side. So then my my left will be mid plus 1. So my left will be 4 and my right will be 4. Now see, we are still valid. We cannot say we haven't found. My left and right both are here. Okay. So we will calculate mid. My mid will be 4 and now we found it. Return, return, return. Nice. Okay. Okay, let's go back. Let's try maybe just for, so now this time what I'm going to do is I'm not going to debug. I'm just going to run and see a couple of test cases if they've run fine. 7, 10, 12, 19, 22. Anything, it's just random. And let's say I want to find 22. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I should be getting 9 here. Okay. I'm going to just remove the breakpoints and put a breakpoint here. Okay. Let's see what we get 4. Okay, okay, okay. We wanted to find 22. Okay. Let's see. Okay, 9. Very nice. Let's say I want to find 100. So I should be getting -1. Okay, good. Let's try one more. 6. Oh, there is a problem, I think, because when I ran it, see, and it never came back. This means my code is in infinite loop. Something is not right. The code is still running. Okay, so 6. Why? Okay, and now we need to debug. Let's see. Okay, my L is 0. This is 9. Okay, mid will be 4. Okay, so my mid is 0, 1, 2, 3, 4. Okay, and I want to find 6, so which is onto the right side of mid. So we will go on to the right side, and this will be 4 plus 1, 5. So my left will be 5 and my right will be 9. Okay, left is 5, right is 9. So mid is 7. So 0, 1, 2, 3, 4, 5, 6, 7. Mid is 7. Now 6 is onto the left side of mid. So we will go on to the left side. So then my left was this 0, 1, 2, 3, 4, 5. And my right is, we want to go into the left side. Okay. Right, looks good. 5 and 7. So 0, 1, 2, 3, 4, 5, 6 and 7. So we have this. We got mid is 6. So 0, 1, 2, 3, 4, 5, 6 is my mid, right? Okay. So I want to go on to the left side. L is 5. This is 6. Okay. Still valid. I came here. My mid is 5. 0, 1, 2, 3, 4, 5. So now, is it on to the left side? Yes, it's on to the left side. So we will go on to the left side. But we cannot go on to the left side because my left is 5. I cannot go on the left side. So my L and M will be 5 and my mid will be 5, and I think we will just keep going. Code has a bug. Code has a bug. So 6. What is the problem? 1, 2, 3, 4, 5. There is a problem. 6 is not present. It should return -1, right? Okay, let's see. Let's go here and here. Okay, let's look at it more closely. L is 0, 0. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is perfect. Mid is 4. So 0, 1, 2, 3, 4. And 6 is bigger than mid, so we will move on to the right side. Okay. Okay. I want to move on to the right side. So which means I will start from 7. Ah, okay, let's do it again. I think I made a mistake. Mid. Okay, I think what I said before is not right. Here, okay, we went on to the right side, which is fine. 5 and 9, 0, 1, 2, 3, 4, 5. 5 and 9. Okay. So we actually left. Okay. Let's see. If when we went on to the left side, mm, I think maybe, is that a problem? Let's see. Yes. Okay. I figured out. Right. I think what I said before in the beginning, I think that's not right. I said we are not including M. I think that time I made a mistake. Why? We are actually including M because we actually check M, right? We check if the value at index M is equal to K and we return. So, okay, yeah. So this means we have included M. So either we want to go totally left of M or totally right of M. Yes, I think I made a mistake. So sorry about that. But yeah, it's logic. I'm just making logic. That's how logic is made. Initially you think something, but later on you realize, no, 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 it should not be happening that way. It should be happening this way. So initially the the logic I made was fine, but that time I made a mistake. That's how you code, fix your code, do debugging, and eventually come to a solution. Okay, so let's see. Let's see if this is working. Let's go back to our original problem. Okay, let's see. This should be returning 0, 1, 2, 3, 4. Okay. Okay, this is fine. After that, we okay, I think we have tested this. Yes, we tried this. Oh, we tried 22. Right, this is okay. After that, we tried 100. Okay, this is fine. After that, we tried 6, which we just did. Okay, I think, I don't know, but I feel this is now perfect. This is looking good. So that's how you make your code, recursive, non-recursive, whatever logic you are building, you come up, you fix it, right? But once you do, you learn a lot of things during that process. And later on, probably you will not make that mistake. So, see, I made a very big mistake here by changing it from m-1 to m. And I think I am not going to forget this thing in a long, long time, right? And when you work on code for such a long time, probably how much time we have taken? Half an hour? I don't remember. So you spending such a long time with this code, this gives you a lot of logic, you remember things, and you won't forget this. So that's all for this session. Thanks for watching, and bye for now.